The singleton pattern ensures a class has only one instance, and the class provides a global point of access to all of its clients. The most common reason for implementing singleton is to control access to a shared resource, for example, a database or a file. A simple implementation of this pattern would be to create a class containing a static instance of itself and a static function that returns this instance. This static function will act as the global point of access. Let's try to understand this with an example. In a chocolate factory, there are computer controlled boilers. The job of the boiler is to take in chocolate and milk, bring them to a boil, and then pass them on to the next phase of making chocolate bars. Now, in this factory, there is only one boiler and multiple engineers can handle it via code. You need to make sure that no material is wasted and only a single instance of the boiler is shared among all engineers. Let's start building our chocolate boiler class. So this is my chocolate boiler class ready here. There are two variables, empty and boiled, which represent if the boiler is empty or if the mixture in it is boiled or not. Then I have the static instance of itself. Then I have the constructor, which is a private constructor, so that any object of this class cannot be initialized apart from this static get instance method. Now this is the static get instance method, which we can call just by using class name. The logic here is pretty simple. If the instance is null, we initialize it. Otherwise, we just simply return that instance. And apart from this, I have the getter functions and some basic logic for filling and boiling the mixture in that boiler. But there is one huge problem with the get instance method above. The problem is if two threads simultaneously call the get instance method, there is a chance that two instances of the chocolate boiler are instantiated. As you can see in this diagram, there are two threads which are spawned. Both of them check if the chocolate boiler instance is null, and which can be true in this case. And both of them create a chocolate boiler instance, which is not desired. To resolve this, we just need to add the synchronized keyword to the get instance method. So we simply go to our get instance method. We say that this is synchronized. The synchronized keyword ensures that a block of code is executed by only one thread at a time. So this will ensure that two instances are never created. Synchronized keywords works well if the code is very simple, like in this case. But if you want to have a very good performance for this code, making this block synchronized won't be as effective. If performance is one of your concern, we can do an eager instantiation of this static instance. What do I mean by that? Whenever I declare this static instance, I can immediately initialize it, which is like this. Empty will be true and boiled will be false. And I can remove the synchronized keyword from here. And in my static get instance method, I can simply return that instance because it is already initialized when this class loads into the JVM. And the IDE is screaming that this should be final, and yeah, we'll make it final. This will take care of all the performance issues that we had while using synchronized keyword. So there are three simple points to keep in mind while using the singleton pattern. Use the singleton pattern when a class in your program should have just a single instance available to all of its clients. For example, a single database object shared by different parts of the program. Second would be use the singleton pattern when you need stricter control over global variables. And third would be to ensure that your singleton implementation is thread safe to avoid any concurrency issues and stuff like that. That's it for the singleton pattern. All the theory and code of this whole chocolate boiler thing, you'll find it in the description. And yeah, thanks for watching.